Assalamualaikum and hi everyone. This is video 5 for chemical bonding. Alright, so we are still in the covalent bond section. Okay, subtopics covalent bond. And then in the previous video, we have learned about Lewis structure for covalent bonding. And then the example that we use were HNO3, nitric acid or oxy acid. Okay, so today we are going to continue with one example for Lewis structure of CO2. Okay, so if we are given a kind of question like this, CO2, and then the question asks us to write the Lewis structure. So the first thing that we need to do is design a solution map. First of all, we need to know the formula of the compound CO2, carbon, and oxygen. How many oxygen? 2. How many carbon? 1. All right. The first thing that we need to do is skeletal structure. Okay, skeletal structure. So carbon O O. Okay, COO. And then we need to count and distribute electrons. Okay, so for example, carbon has how many valence electron, oxygen has how many valence electron, and finally we can identify the Lewis structure, which is octet one. So now, all right, so we designed the solution map already. The first one is we write the skeletal structure in. For CO2 is easy. All right, so first of all, we need to define how to write a skeletal structure. We have to find the least metallic atom at central. Okay, H and halogen is always at the terminal, and it must be symmetry. So in this case, this is symmetry because carbon in the middle, oxygen on the left, and oxygen on the right. It is symmetry. The next one, you have to count the valence electron. For oxygen, we have a 6. How many oxygen? 2. So 2 times 6, 12. Carbon, 1 carbon contains 4 electrons. So 4 plus 12, 16. So total electrons for CO2 is 16. Okay, so this is the periodic table. So carbon is in group 4A and oxygen is 6A. So 4 electron valence electron and 6 valence electron for oxygen. Okay, next we distribute the valence electrons. Okay, first we have to make up the bonding electrons. So now the bonding electron must be between O and C and O. So this bond use 2 electrons, this bond use 2 electrons, so 4. So 16 minus 4, now we have 12 electrons left. All right, so how to distribute these 12 electrons around the atoms? So now we have to put 12. We have 12 electrons, right? So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So there is it. We use all 12 minus 12. We don't have any more electrons. So now we look at the oxygen. Oxygen here 1, 2, 3, 4, 5, 6, 7, 8. Already octet. This oxygen on the right 1, 2, 3, 4, 5, 6, 7, 8. Octet 2. So the one with no octet yet is this carbon in the middle. Why? Because 1, 2, 3, 4 should be 8 electrons altogether. So now we have to complete the octet. So there is not enough electrons to complete the octet of the central atom, in this case carbon. So we have to bring in pairs of the electrons from oxygen on the right and oxygen on the left to make multiple bonds. And so we can count now. So this is 4 electrons, 5, 6, 7, 8, enough. 4 electrons, 5, 6, 7, 8, enough for this oxygen. So carbon here 1, 2, 3, 4, 5, 6, 7, 8. That's it. Okay, so CO2 Lewis structure for CO2 is C double bond O double bond O. Okay, so we can check again. All right, so now we got C for electrons, oxygen 2 times 6, 16 electron at the beginning. And finally the bonding, we can see bonding is the one that has no dot symbol like this. So this is bonding electron, this is non-bonding electron. Understand, this is non-bonding electron. Those with dots is non-bonding or lone pair. The bonding is the one with the bond structure here. So for bonding electron 1 2 3 4 5 1, there are 4 bonding, which is one bond represent 2 electrons, so 4 times 2, 8 electrons. Lone pair 1 2 3 4 5 6 7 8. Okay, so 8 plus 8, 16. So now all the electrons accounted for and follow the octet rule. So okay, we move to write Lewis structure for polyatomic ions. Okay, so before this, it's a stable compound. So polyatomic ions, okay, contains, for example, C, the triple bond N, and then the charge is -1. Right, the procedure is still the same. Okay, the only difference here, we have to count for the valence electron coming from the charge. Okay, so for example, here NO3 minus. So the first step, we have to draw the skeletal structure. The one least electronegative is in the middle, and then it must be symmetrical. So now it's very symmetrical, right? This O can be put down here too. It's up to you. Okay, so count the valence electrons is the second step. So nitrogen has 5, oxygen, there are 3 of oxygen, so times 3 times 6. So 18 electrons minus 1. Why minus 1? Because we have 1 electron charge here, NO3 minus, right? So 18 plus 1 plus 5 is 24 electrons. Now, put the bonding electron first. 1, 2, 3. So meaning that we use 6 electrons. So 24 minus 6, 18. Now, we have to use the 18 electrons to complete the octet. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. Enough. There is no more left electrons, but the nitrogen here is not octet yet. The other atoms are all octets. Okay, already octet. What to do? All right, so we have to move the 2 electrons here, the pair, one pair of electrons here, to make up a double bond. All right, so it becomes 1 double bond, 2 single bonds, and then the others are lone pair. All right, so that's it. Okay, that's it for, sorry. Okay, so that's it for that. Okay, NO3 minus. So exception to the octet rule. Yes, we have some exception to the octet rule. Molecules in which the atom has less than an octet, for example, hydrogen, lithium, beryllium, and boron. I've said this. I've mentioned this a few times because it's electron deficient. Okay, so boron has only 3, beryllium is only 2. Okay, lithium 1. All right, so it's an atom less than an octet. Molecules in which an atom has more than an octet, yes. For example, phosphorus. Okay, we call it expanded octets for elements in period 3 or below. Okay, using because it's using empty valence d orbitals. We are going to discuss this later. Okay, and then molecules with an odd electron, for example NO. Okay, so this is actually the exception to the octet rules. So we have some practice here. Please try yourself this as a homework for today and check the answer with your lecturer. See you in the next video, and thank you.